All right. Better work conditions, better pay. Everybody, this is Jarris White. If you've ever needed help with Python and you don't know who this is, you've done yourself a terrible disservice. He's the tutor that works downstairs, soon to be adjunct professor, I believe. Are they roping you into that?
Maybe, I don't know.
I was trying to figure how he isn't already, but so. Give him respect. Listen to him. He knows a lot. He knows a lot more about Python than I do, at least in practical terms.
Yeah, I mean,
so he has a lot more practical. He's actually going to show you some pretty cool practical stuff you can do. So I'll turn it over to him, Jarris.
the voting script is still downloading because it's pretty big. But all right, so I'm more gonna talk about what you can do with programming in general, in a more real sense. I've written quite a few scripts over the past few years. Most of that began trying to do homework a little easier. I don't know if any of you have taken the crypto class yet. It's pretty tough. You don't want to do it by hand. Oh, there it goes. So automating that kind of thing is amazing. Let's make sure it works real quick. So, does anyone know what a Caesar cipher is?
I do.
So, it's basically where you take letters and just shift them by a certain amount. It's the first thing that they have you do in the crypto class, and it's not super hard to do, but at the same time, the tests are all encrypted with Caesar cipher.
He doesn't tell you to shift anymore, does he?
He does. Well, there's like a bonus with like a random shift of a random number. So, let's see. Code for Caesar. Lot of different ways to do pretty much anything when it comes to coding. Any way you could wrap your head around a problem, there's some kind of logistical way to do it. A lot of the code that I've thrown in here with these args are just for quality of life purposes. You really just need to get input in some way. So these sys.args are whenever you call a command line program, you can give it an argument, like whenever I call pi, I give the argument of my file. Any arguments past that will be passed to the program itself. So you can access those once you run the program by just calling the built-in system.args. But the meat of this program is taking in a letter and then converting it to, well, first figuring out what alphabet it's using, because I want to preserve whether it's uppercase or lowercase, and then finding the location in the alphabet. So if they put in C, that's location 3. So Python has built-in alphabets, ASCII uppercase and ASCII lowercase. Once I find what position it's at, I can change the position by the shift. So if I wanted to shift by 3, you know, A becomes C, C becomes whatever, and then modulus 26. So modulus is a fancy, commonly used programming thing where it takes division, and I'm sure you all remember from elementary math where before you had decimal places, you had remainders. This just gets you the remainder. So if you modulus 26, you take the length of the alphabet and say, so if for some reason I shifted past 26, what spot number is 28. What letter is that? Well, it doesn't exist. You'd want to round down, back down to 2 for B. So if you modulus 26, the remainder is 2, and that's really the letter that you want. And then we grab that letter back out of the alphabet. So this is fancy. Python uses strings, let you take letters one at a time, or
You use a 4 letter.
you could loop
They've
through
seen that
letters,
4 letter in text.
or you can I should use idle. So if x equals ABC, I can slice this, and I say I want position 1 out of this string. And because in most programming languages, not all, things start at 0, A is 0, B is 1, and C is 2. So if I want spot 1, it'll give me B. Or if I want spot 1 to 2, should give me, oh, that's right. It's, I believe, yeah. You can get the whole string, just parts of the string. Each programming languages has a different way to do it. Java is called substring. The point is that once you figure out the logistical way that you want to do it, you can Google the rest, essentially. So the specifics on how to get a specific letter is commonly taught and easy to find on something like Stack Overflow. So Caesar, now I can throw in a bunch of text, whatever text he gives me for the test, and then try Caesar cipher of whatever shift I think it is. Let's try a different program. I'd like to try.
Spoiler alert: next week we're doing Caesar cipher, so.
Oh.
It's good. It's good that you gave him just a little kiss of it.
Yeah. A lot of places don't use the modulus 26.
They use like if I use the ASCII table, like was it order number or whatever, or.
Yeah. A lot of people, like, whenever I first did Caesar, I did like if greater than 26, do it minus 26, which works too. It just doesn't work for really high numbers. Let's try dice. Pretty easy. Basic number, random generated numbers. Python's great with numbers. Oh, I'm using secrets instead of random. It's just Python has a more secret or better generated random module called secrets. It taps into your operating system's way of finding random numbers. So instead of you relying on Python's algorithm. But the meat of this program is just secrets. Oh, where is it? Oh, here it is. Yeah, random.randint. 1 to the dice type, so like a 6-sided dice. So 1 to 6. Once you have the meat of your program, you can start adding fluff, like putting specific different groupings in a function. So I have a roll function that does this for me for however many dice I want to roll. And that way I can call roll wherever I want, as many times as I want, without having all of this code. Makes it a lot easier to understand. Now I can just roll specific dice type a specific number of times.
Great for Dungeons and Dragons.
Great. For games, most games use some kind of random number generator for, damage or moves, enemy movement, something to make enemies look more lifelike. So like.
However many, because I mean, everything in Dungeons and Dragons is,
Yeah.
you walk into a cave and there are 12 goblins.
And you don't just use 6-sided dice. You have 20-sided dice, 12
using wild
percentile.
Magic, use 100.
Yeah. All right. So. Oh. Should I do?
And actually, the dice roll program is going to be one of your final possibilities that you guys can do. So don't just copy what he did, because I'll look at the video, and if your code looks suspiciously like his, you'll get an F. I will fail you. So don't cheat.
I didn't show it very long, but
yeah. These kids are resourceful.
I hope so. Should I do context for the voting program? Or is that bad?
Give it a little bit of background. I mean,
okay.
Maybe you don't have to use the exact what you did it for, but
okay. So
generic.
Google Forms is a way Google provides. Pretty sure all Google Drive accounts. You can make a Google form in your Google Drive and share it to people. People, go in. It's like a small quiz thing or a voting. You get to have whatever questions you want. Let's go and see if the form's still alive. Yeah, so this is just one that Roy set up for me to test on. It's pretty much identical to the real one. It requires an email. You pick your option, and then you submit. So how HTML works is everything has a class, and the class is what tells it. It's what tells your browser what's what. So if I wanted to style the email box, I do it on the Quantum Whiz text input, paper input. This is Google stuff. It's really annoyingly complex, but I'm just looking for this. And once I have that, I know where I need to input. And someone made a module out there called Selenium, and it takes most web drivers. So Firefox uses a web driver in the background to do basically all the heavy lifting. It's called the Gecko driver. Chrome has one called WebKit, I think.
That's right.
Selenium supports Edge, Opera, whatever. The main idea I have here, set this to false, is I make a little driver, and that spawns an instance of the browser, and I can tell the driver to go get a website. Then I can tell the driver to find an element by the class name, which is what we just looked up. And I gave it the stupid Quantum Whiz text input. And then I told it to, on that element, type in the letters for the string user, which I created, you know, some random username. The thing with Python is that there's a module for everything somewhere out there. You can pip install just about everything. Someone made a module called names, and names just gives you a random first name or a random last name. So I'm generating random first name dash last name at raider.rose.edu and then typing it in. And then I tell it to find the element by class name, this long string, and then click on it. And then find the element by class name, this, which is the submit button, and click on it. Then I delete all the cookies, I kind of reset the profile, I increase the counter,
So you can do it again.
and we do it again, because this is in a while true loop. And
Which are dangerous. Be careful when you're using while true. If you don't put a break, it's gonna go forever and jack something up.
you could always close the window.
Or kill the daemon if it's on a Unix thing, which I've done that a few times on Unix. So.
I always recommend having some kind of counter, even if it's not important, just so you know your program's actually running and it's doing something. Let's go. Run it. Oh. You can probably guess what the fake user agent module does. User agent is the
If names.
oh. Whenever your browser makes a request to a website, it sends the user agent, which is what version of what operating system you're running, what version, what browser you're using, you know, Firefox in this case, etc. So if I generate a random user agent, they're less likely to notice. Is Firefox installed?
Yes.
Okay. They're less likely to notice that, you know, it's not actually a person doing anything. Oh. Hang on. Oh, I didn't save it. There we go. The problem with using the Gecko driver is that it does take longer than just sending requests. So here's it actually working.
Wow.
It types in a random name.
Beth Campbell,
William,
something,
Richard,
Robert, Bobby,
uh,
Tessa, Teresa, Christian,
yep.
Irene, Anita.
Clicks the first button and then clicks submit. And then it goes back to the website forever because it's in a for loop. Or, sorry, while loop. And then I made a little text file because I like logging. Voted.txt. Here it is. It's just everyone who ever voted. This is 2 million long. I ran this for like 20 minutes. Unfortunately, I ran it on 2 machines at once, and they didn't like that. I was getting like, apparently like 30 requests per second is where Google starts to not like what you're doing. And
What do they do? Do they just freeze the window, or?
every time you go to the forums, there's a CAPTCHA instead. They just redirect you to a CAPTCHA. Originally, whenever I was writing this program, I was looking at just sending requests, because you can send basic requests to a web page. Say, you know, what page you want, just give me the HTML. Google likes JavaScript though, and programming and a way of interpreting all that JavaScript so I can set cookies correctly and get my ID is a pain. Whereas Selenium literally just opens an instance of a browser for me, and I can tell it to click on things. There are ways to do this for everything. Game engine creation has a module to do what you want to do. You just have to kind of look through the documentation. Let's pop over. Let's try something else. This is the other instance of me using Selenium, where someone wanted the warranty expiration date for a specific HP computer service tag number, or be able to give it a service tag number, and it'd go out to HP's website and give them when the warranty was expired, or when it will expire. So again, I have my driver. If I try to, does anyone know the difference between 64-bit and 32-bit? No? Okay. So CPU architecture, designed originally by Intel, the whole x86 lineup was great, but it had a lot of severe limitations. So they upgraded their whole system to allow specifically more memory was the big one, more than 4 gigs of RAM, and unfortunately, to that process, they're not backwards compatible. So you have to build a new EXE for 64-bit and 32-bit computers. So here, try accept. Try to load the 64-bit version, but if that fails, load the 32-bit version, the older. This will run on just about everything because it's the old stuff. Then get the website, find the element by the ID, type it in, and then click the button. Not everything will be that easy for all projects. Specifically this one, because HP has you go through five different web pages to get a SSID and a cookie, and reset the SSID, and then generate it again. And doing that all in pure Python is unreasonable, especially when the cookies are set by JavaScript, which are client side. Whenever you go to a website, JavaScript is is the programming language that's run on your browser to make things appear dynamic on the page. So whenever you're interpreting the web page, you have to deal with that. Whereas Selenium will do it for you. Let's look at some other programs. Tic-tac-toe. That's fun. Let's just run it. Alright, so tic-tac-toe, pretty simple idea, 3x3 grid. Do I want to go first? Usually, you want to go first if you want to win. And then, obviously, this is command line, so there's no clicking. You have to accept some kind of input. And when I do this, you just have to think of the logistics of making this happen. What I'm really doing is I'm just clearing the page each time and printing all this stuff again. the problem isn't usually with making a game not having the tools available. It's not knowing how to use the tools you have available. Pretty sure this bot would beat me. Oh no, I won. If the bot goes first, pretty sure it wins every time. See the code for that. Put everything in function. I put everything in function. So every time I want to print the board, I just made a function that does all of the code that handles printing the board. Puts X's where X's need to be, puts spaces where spaces need to be, and vertical lines.
Make a chessboard out of this, right?
Definitely could do all of chess. You could even do a bot that could beat you in chess. Just here. It's just how much time do you want to spend? This is a little long. This is almost 300 lines just for tic-tac-toe. The problem is handling the fact that it's just text. Most game engines will handle that for you. You just tell it what to put where. So you put like an X here, you put an O here. So every time something happens, I evaluate if someone won. I have a function to get cell numbers, to change the board. This is for the bot. It looks for openings to see if where it can win. And then here's the function for the AI actually moving. All these functions, when I declare them, they don't actually do anything. So down here, in the meat of the program, I have to actually call those functions when it's good to call them. Let's see what else. Roy could show you guys better circles.
Yeah, he showed us. Is that the circles with the like the triangles in it?
Yeah, and the four turtles.
I don't think he showed. I don't think he actually showed us running it.
Oh, I can show you running it real quick. So, oh, I put it to more than 4 turtles. Even something limited like turtle, you can only do one at a time. I'm tricking it into doing 10 at a time by creating 4 turtles, which it's fine with. But then each time the turtle moves, where is it? Yeah. Every time it goes to draw something, draw a circle, instead of actually drawing it, I'm having it put it in a queue, process queue, which queues are built into Python. Might as well be a list. It's just something that you can put things on and then take things off. So queue is first in, first out. AKA the first thing you put in is the first thing that'll come out. So I am multi-threading this, essentially. So it can do more than one thing at a time. Where is it? It's terrible.
Slowly, but
Much faster with 4. So when you first get into trying to do multi-threading, which is the ability to do more than one thing at a time, it sounds nice to just throw the capability in there and run it. But first, you have to actually come up with the logistics on how that would work on a step-by-step basis. So instead of just throwing it in there and say it does multi-threading, what two threads run at the same time? What do they do? And how do they interact? Because where am I actually starting the threads? Here we go. So I'm doing 4x in range on the number of turtles I set. And for each one, I'm creating a turtle. And I'm setting up the thread. And then I'm starting the thread. The problem with this was that it crashed immediately because you can't have two threads writing at the same time. Or at all. All the writes have to be from the same thread. So, to combat that, at the end, I just throw down a process queue, and that's the one that actually moves all of the turtles. Everything else is just setting up to the queue. Everything else is just putting moves in the queue, say, I want to move here. Well, okay, we'll get to you in a minute. And I limit the queue size so that we don't have 100 assignments to do in the course of a minute, because these turtles move pretty slow, and you can come up with moves to do pretty quickly.
You didn't say it.
Oh, I didn't, of course. Yeah. The problem is that it's actually not much faster than just one turtle. Despite what you'd think, because they can only move one at a time, and turtle is very inefficient. When there's just one, it moves quite a bit faster. And that's something you have to think about. A lot of people say, well, there's a lot of problems recently. Games historically have just used one CPU core, because they typically happen. There's one thing happening at a time because everything's happening in real time, and you don't quite realize that you have there's a whole logistical issue with actually throwing it in so that it can access all 4 cores on your computer at once, because that would be, you know, quasi real time, because there are 4 things happening at once. It's not actually all happening sequentially. Chat program. In Python, oh, I need to, that's right. So, in Python, sockets are the general way to communicate over a network. You open a socket, which would be the server listening, and then you connect to that socket. Oh. Pip is amazing. Alright, so opening connection with this IP address on this port. This is just the default loopback address. 127.0.0.1 is my computer. It's always your computer. So I'm just limiting this to this computer. But if your firewall allows, this socket would be open, not this one, the server. This socket would be open for any IP to connect to on that port. Sockets. Oh yeah, the return port. So sockets are a little confusing at first because let's go down. You connect on the port, or you open the socket on the port, and when a client connects, they use your port as the destination, and then they come up with a random ephemeral port. Not that one. So that it creates essentially a socket between the two to communicate. So now I can open what's the server? Alright, so that's right. So now we've got me and Jack both connected to the same server. We have different return ports because it picks a random one, and then I have it generating an ID because what if both of these people pick the same name? You don't want to refer to them just by name. Say, if one of them disconnects, you don't want to disconnect everyone named Jack. It's a problem. So by default, this is by how Python does text output. This isn't really reasonable to begin with, except when you have the module Colorama, which lets you have unique. I want to find it. Oh, it's on the client. So the problem is that you have the prompt here, and when Jack types something, it replaces your prompt and clears it, and then puts you on the line below. That's basically just a logistical issue. You have to figure out how you want to handle that specific instance, that error, or not error, but a problem to tackle. And to be honest, programming is just a series of problems to be tackled. Once you figure out how a socket works, you do a basic socket connection, and then you have to figure out how to actually do the chat part, where how do I print people's messages above where their prompt is. Took me a while to figure out how to use Colorama to do that. Oh, there it is. So this is the special key sequence to erase the stuff above you, which is annoying, but that's how it works.
Is that something built within Colorama?
Yeah.
X1B, 1A, X1B.
I believe those are actually special. Those are Unicode.
Okay, yeah, slash.
I can't remember why. The very specifics on why those. But Colorama also, by its name, has colors. You can make the text yellow, you can make the text red, etc. It's basically what it was built for, making text a different color, but whenever you open that can of worms, you open the ability to do other Unicode commands, like erasing the line above you. Matrix, maybe.
Do one more.
Alright. You all seen The Matrix? So, I like this one just because it's a great visual representation. So, I'm creating a bunch of lists of random characters. And then I'm going through and printing them one at a time, and I'm saving where their locations are. It's basically just one long problem of figuring out where to put things. So I have a little dictionary of where they're supposed to go, you know, how far on the screen. This one goes spot 3, this one goes spot 5, and then how long they have. So this one's, you know, 10 long, 20 long, and then once it reaches its length, it kills it, deletes it, and starts another random one somewhere.
But then still prints itself a line above. Is it constantly reprinting itself, or is it just?
It's constantly just printing. You see the scroll bar. It's just going. I'm not clearing the screen or anything. Fairly basic. I ultra commented this one because it was for a presentation for the summer thing. If you want any of these programs, Veneer Cipher, Flask is cool. Flask is a module someone made so that you can host a website in Python, and then you go to the address for the computer you're running it on, usually localhost 127.0.0.1, and then it hosts the web page that you give it. Most web pages are HTML or JavaScript or both. Flask is just one of those things. Flask was a lot of work because of the documentation. Specifically, something like that, it's a massive module. You have to go through all of the documentation for that. I don't think I really have any games other than Tic-Tac-Toe. I really just made Tic-Tac-Toe because I was reading somewhere about programming interviews, and someone was like, yeah, they asked me to write Tic-Tac-Toe in 30 minutes where the AI tries to lose. I was like, I want to try that. Just trying different things, practicing Google. A lot of Google.
Google is your friend. Stack Overflow is your friend.
Stack
Essentially,
Overflow is great.
I want to touch on what he said in the beginning. Like, once you have an idea for something, think about how. Like, there's so many different ways. I mean, there's really no wrong way to do it. There's bad ways to do it, but even a bad way can be fixed up to be a decent way.
Yeah.
So, like, think, you know, step by step. I want to do like the Caesar cipher one. Say you wanted to add like a decryption. Like, you know, Ken gives you something. He doesn't say what, you know, what shift it is. So you think to yourself, okay, well, the is a really common word in the English language. So essentially, go through 1 through 26, although 26 would be done. So 1 through 25, and shift it. And then once you shift it all, search string for the. If found, that's, you know, this could possibly be it. Then print it. If there's no the, you know, jump to the next one. So that would be a way just to brute force decrypt it. And I said it, but how would you go about doing that? So that's when the mind games come in. It's like, well, you know, I could do an if statement if, you know, string location or string position. That's PHP, but whatever the Python find, that's probably it. And if there's no then you gotta have a backup. And if you go all the way to 25 and you didn't find it, what's another common word? And, in. Make sure it's space, in space, so it's just the word in by itself. So.
Something like that. You really want to modularize it, meaning once you have the code that converts whatever string to shift 3 or shift 4 or whatever, put that in a function so that you can call it at any time. So for shift 1 through 25, you can call it 25 times easily without having to, junk up your code with
25 iterations of the same.
Yeah. So just throw it in a module or a function, and then once you know that function works, it's easier to understand that you could just call it, and then you figure out what to do with the output. Also, text editor. Do you have them use idle?
I gave them the choice between idle and Notepad or Sublime Text.
Find a good editor that you like. Notepad's great. Idle works. Whatever makes you feel more comfortable actually writing the code. Some of them do text prediction. Some of them normally Notepad++ has the double click to highlight, but this one doesn't.
Yeah. Like the whole line, or.
No. Like if you double click the word time, then all other times will be highlighted.
Oh right, yeah.
I don't know.
I don't think I have it. I think I just have it set up for basic. I don't think I have it set up for Python.
Oh, okay. Yeah.
Any questions? He threw a lot of information at you guys, but I just kind of wanted to show you guys what you can do, because you will in cryptography Ken will say make a Caesar cipher. He's not gonna spoon feed it like I'm gonna. He's gonna say do this, and he's gonna say okay, make an Avenir cipher. Here's a basic idea of what it like. He'll give you like the meat of like this is how you look for stuff. Now make it. So he'll give you like 2 lines, and you got to build an entire code around it. So it's easy just to Google stuff and just does Python have an Avenir function in it? Cool, it does. Pip Avenir or Vignere or whatever it's.
Yeah.
Vignere cipher. I think that's what I first called it when I saw it, Vignere. But it works smarter, not harder. As Jared showed you, he could have dealt with all the crap that Firefox and Google threw at him, but he found Selenium that handled a lot of that for him. So rather than coding an extra 80 to 90 lines in his program, he could just use something that was already built. So that's one good thing about Python. There's lots of add-ons that make your life easier.
Anytime you're parsing some kind of HTML, beautiful soup is great. It sounds weird, but it basically just makes it super simple to go through HTML. Because if you look at the source page for this website, or any website really, it's terrible to look at. And computers can handle this perfectly, but we can't. So we need some kind of intermediate to make things easier.
Any questions? If you don't know, if you ever need help in a programming class or pretty much any class, he's downstairs in 131. He can help you out. Go annoy him. It's what he gets paid for. So hopefully he'll start teaching, because I'm tired of getting 4 classes of these a semester. Which I only have 2 this semester in this class, but I'm like the low man on the totem pole, so they always give me stuff like this. So it'll be nice to share the burden of carrying the 1 ring of intro to programming. This is a pretty tough class to teach and to take for you guys, especially when you guys have 0 interest in programming, 0 background in programming. This is a pretty tough class. So
basically, the idea is that if you can do it on a computer, you could program it.
Yeah.
Some way to do it.
Because he's
For
gonna have
you.
he's gonna give you AES, an AES cipher, essentially. Like he's gonna give you some numbers, and then you got to run it through part of the AES encryption. And doing it by hand it's good to know. You should do the first one by hand, but after that, it's painful because you can make a mistake that you just overlook something, miscalculate, add another number here and there, and your entire answer is wrong from then on out. And he doesn't grade partial; he grades that's the wrong answer.
Yeah.
So once you know how to do it, then you can open up Python and think, okay, let's do this step by step. Let's redo the one I already did and I know is correct, and make Python spit that out. And once you do that, whenever you get to his test and he gives you something to do on the fly, you can just plug those in and hit enter, and you're done. Rather than possibly ifing up your test. So.
And once you know your program works, it's very unlikely that it'll actually break. So if you know it works, it doesn't make human error. So it doesn't, accidentally type something wrong.
2 + 2 will never equal 5
Yeah.
for a computer. Even though in your stupid head it might.
Unless you have some serious hardware issues.
Yeah. You have bigger things to worry about.
Yeah.
Well, if you guys don't have any questions, go ahead and stop the recording and
Oh, that's right.
let y'all up out of here.